Complex or disguised quadratic equations. We know that quadratic equations, they are of the form ax square plus bx plus c, and we have always been saying that quadratic equations have the highest power, which is a 2. But let's say that you are given an equation so that the equation is x to the power 4 minus 4x square minus 21 is equal to 0. Now here the highest power is no more a 2, but such equations, they can be brought back to the form of quadratic equation by a simple method of assumption, where we say, or we can assume, that let x square equals to m, so that if I square this value, I will be having x4, which I can say is m the whole square, giving us x to the power 4. Meaning in terms of m, I can bring it back to the quadratic form, so that now the quadratic equation is m square minus 4m minus 21, which is equal to a 0. Solving and taking the factors of 21, I will be having m square plus 3m minus 7m minus 21, which is equals to 0. Or I can say it's m common, m plus 3, minus 7 common, and m plus 3, which is equal to 0. Or I can say this is m plus 3 and m minus 7, which equals to 0. Therefore, m will be equal to a negative 3 and m will be equal to a positive 7. But in terms of x, I know that m was equal to x square, so bringing it back to the x form, I can say x square equals minus 7, or x square is equals to 7. Under root of a negative number is not possible, so I'll simply say that negative 3 under root is not possible, but there is a value of x which is going to be a plus minus under root 7. So this is how we are going to solve complex or disguised equation by the method of assumption. Let's do another question. We need to solve 2x to the power 6 minus 4x to the power 3 plus 1, which is equals to 0. Again, I can see that this is not a quadratic equation, but I will be bringing it to the form of quadratic equation by assuming that m equals x cube, and therefore m square will be equal to x cube the whole square, or we can say that m square is equals to x to the power 6 here. So this equation in quadratic form can be written as 2m square minus 4m and a plus 1, which is equal to a 0. Solving it by the formula, I will say m will be equal to a negative times negative 4 plus minus under root b square, which in this case is a negative 4 the whole square minus 4 times 2 times 1, or m can be solved and I will be having the values of m, which can be 4 plus minus 2 under root 2 divided by 4, or I can take 2 common, so that I will be left with 2 plus minus under root 2 divided by 4, or I can say that my answer is 2 plus minus under root 2 divided by 2 here. So these are the two values of m, but I need to have the value of x. Therefore, I can say that it's x cube, which is equals to 2 plus minus under root 2 divided by 2. Solving for the x value, I should say it is x 2 plus minus under root 2 divided by 2 to the power 1 by 3. The two values of x are going to be 1.195, or I can say to three significant figures, it's going to be a 1.20, or the next value that I can have for this is going to be, so the two values of x, possible values of x for this equation is x equals 1.20 or x equals 0.664. So this is how a disguised quadratic equation can be solved. So let's do an exam type question. Find the real roots of the equation 8 over x4 plus 5 over x square, which is equals to 3. I can take the LCM and I can say that this is x to the power 4 giving me 8 plus 5x square, which is equals to 3. Or solving it further, I can say this is 8 plus 5x square, which is equals to 3x to the power 4. Or making a quadratic equation, arranging the terms, I can say this is 3x to the power 4 minus 5x square minus 8, which is equals to 0. I can see that it's a complex disguise equation. Therefore, let m equals x square. Therefore, m square is going to be x square, the whole square, giving us x to the power 4. So now this complex equation can be written as a quadratic as 3m square minus 5m minus 8, which is equal to 0. So after factorization, I can say that this is 3m common and m plus 1 minus 8 common. I'll be left with m plus 1, which equals to 0. And the two roots are m plus 1 and 3m minus 8 equals 0. Therefore, m will be equal to a negative 1 and 3m minus 8 equals 0. M will be equal to a 8 by 3. But we know that m was basically equal to x square. M was basically equal to x square. So substituting m with x square equals 1, negative under root not possible. Therefore, this value shall not be giving us any roots, but x square equals 8 by 3. I can say that the root is x plus minus under root 8 by 3, and this is going to be the root of the equation, the disguised or the complex equation that we shall have here.